Okay, so for this lesson, this is graphing a function rule. So the nice thing about this is they'll always give you the equation. So your choices are to do a couple things. You could, when you're given a function rule, you could graph it, make a table, whatever. So on this one, this is actually really easy because you know that this is a linear function. The y-intercept is 1 and the slope is negative 2 over 1. So you could literally go ahead and just go here and you could plot a point at 0, -1 if you wanted to. You can go to 0, -1 and plot a point. So you go ahead and go to 0, +1, and then the slope is -2 over 1. So I could actually go up to 1, 2, left 1 and put a dot. Or I could go down to 1, 2, right 1 and put a dot. And then you can see that that would make a line. You could connect that if you wanted to. Just draw it in. But these would make a straight line. You don't really need to do the table of values because it's a linear function. Okay. So this is the same one. This is for the got it. This is a linear function as well. On this one, the function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 cubic feet, what is a reasonable graph of the function rule? Well, with that one, you kind of got to think a little bit. You just got to try to do a few uh, trial and errors. The first thing I'm going to notice is that the function rule itself is in fact a linear function. So that's good. All right. So if I were to make a table, if I were to make a table of values, I would first start out with here would be my C and here would be my W. And the first thing I know is that if I'm not carrying anything at all, where C is I believe, the capacity, if I'm not carrying anything, my y-intercept is 30,000 pounds, I think. Okay. So then what I could do is I could just try different values that I want. Now, what I could do is I could try 50. I don't know. I'm just going to make anything up. I'm just going to do 50 because it's pretty easy. I'm going to do 50, and then I'm going to plug 50 into this right here. I'm going to do 146 times 50 plus 30,000, and I believe that gets me 37,300. That gets me 37,300. Now, where did I get that number from? I just went ahead and plugged in 50 for C and used my calculator. Then I don't know. I'm going to do 100, I guess. If I plug 100 in, I get 146 times 100 plus 30,000, and I use my calculator on that, and I think I get 44,600. And again, I know I'm not showing how I'm doing this, but I'm just telling you I'm using my magic calculator. All right, and then next I'm going to go ahead and do 150 because it just seems like it's getting bigger here. And the capacity they said is 200, so I'm going to end at 200. Okay, so I have these 1, 2, 3, 4, 5 points. So 150,000 or 150 times 146 plus 30K is 51,900. 51,900. For 200, I'm going to do 200 times 146 plus 30,000, and I get 59,000. I think it's 59,200. Again, I plugged it in for the value of C. Now, when I plot this, I only need to do this side right here. This is going to be concrete. I'm going to call that C, and I'm going to call this W. And 0, 30,000, and I'm going to put like a dot right here. And then I guess I'm going to go up here, and here's 50. And then 37,300 is probably like right here. And then I'm going to go 100, and it's going to be up here somewhere. And eventually you can see that it's going to be a line. Okay, so no big deal. That was actually pretty easy. These two right here are all involving lines. Okay, moving on to the next one. Here's Now you're going to have to do the got it's on your in your packet, but I'm just going ahead and making it a little easier, going through the problems pretty quickly here. A few things I do want to talk about on this is a key concept we need to know is the concrete or continuous and discrete graphs. Continuous is when it's just an unbroken line, and discrete would be just dots, like broken lines or whatever. An example of a continuous would be that last trucking example, whereas con- a discrete one would be, if you're like in this example, this is probably going to be, well, it could be how much money you're making, or something like that. It varies from number of papers you're going to deliver or something like that. It's not a continuous graph. We'll talk more about that in class. This one, you have to it says identifying continuous and discrete graphs. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation. Graph each function. Is the graph continuous or discrete? So here you have 1 gallon of milk makes 16 ounces of cheddar cheese, and each wheel of cheddar cheese costs $9. So when you're going to do this, what you can do, probably the thing that makes the most sense, is to make a table of values for this. So if I just go right here and I go ahead and I make something, in this case, 1 gallon of milk makes 16 ounces. I'm going to say, okay, I'm going to use M for milk, and I guess I'm going to say W for the cheddar cheese, right? Now in this case, I'm going to start out with, if I use no gallons of milk, I make no cheddar cheese. If I make 1 gallon, if I use 1 gallon of milk, I'm plugging in to see 1 gallon of milk, that makes 16 ounces. If I use 2 gallons of milk, that makes 32 ounces. Now, if I were to graph this, I only need to use this right here, and I say 0, 0, and then 1, and then here's 16, and then 2 and 32. But the question is, can I make a half a gallon? Can I put in a half a gallon of milk and make 8 ounces of cheese? Well, yeah, makes sense to me. So you can connect these guys with the smooth curve, right? You connect them with the smooth curve, and here's the thing. This one is what we call continuous because it can be connected with the smooth curve. Let's look at this one. We're talking about each wheel of cheddar cheese costs $9. So I guess what I'm going to say is the number of wheels sold. So I'm going to call that N, number of sold. And I make another table, and I'm going to say, I'll put money right here for cost. So if I sell if I sell none of those, then it costs. If I make none of those, then I have no cost. If I make one, it is $9. If I make 2 wheels of cheese, it's $18. Now, here's the thing: can I make a half a wheel of cheese? No, you really can't. But if you graph it, you got 0, 0 right here, and you got 1, 9, looks something like this, and then 2, 18 looks something like this. I can't connect these dots. Although it fits a linear pattern, it keeps going up and up. I can't make 1.5 wheels of cheese. So this is what we call discrete. This is discrete data. Okay, still fits a linear pattern. You can still write a rule for it, but it's really a discrete data because you can't connect those dots. It's not a very smooth curve. So the guide for this one is kind of the same thing. Just so you guys go ahead and come up with the table of value. Think about, can you fill, like this one's talking about pulling gallons. Can you have a half a gallon, or can you buy half a ticket? Those sort of things. And some of it's a little bit of extended common sense. Okay, looking at this, what is the graph of each function rule? This is y equals the absolute value of x minus 4 and y equals x squared plus 1. For these ones, what you need to do is, to start them all out, you have to make a table of values for each one. So if I want to make a table of values for this one, for A, I'm just going to go ahead, and it's very good practice when you're dealing with absolute values to go ahead. I'm going to use -2, I'm going to use -1, 0, 1, and 2. Now, if I plug negative 2 in here, the absolute value of negative 2 is 2. 2 minus 4 is negative 2. The absolute value of negative 1 is 1. 1 minus 4 is negative 3. 0, absolute value is 0, so there's a minus 4. And then 1's absolute value is 1, so then there's a minus 3. And then 2's absolute value is 2 minus 4, and there's a negative 2. Okay, now with this one, if you're going to go here, you're going to go 0, negative 4. So it's 0, negative 4, and I'm going to go over to negative 1, negative 3, 1, 2, 3. And then I'm going to go to 1, negative 3. And then I'm going to go to 2, 1, 2, up, down to negative 2, 1, 2. And then over here I'm going to go left 2 and down 2, 1, 2. And so what this is this looks like the letter V. This looks like the letter V, and that's the absolute value. Same thing with this other one. This other one, you want to make some negatives and some positives because they're you can tell that they're non-linear functions. So you want to make some negatives and some positives here. So this one, just go ahead and make an X and a Y, and you do negative 2, negative 1, 0, 1, and 2. So what's negative 2 squared? Well, that's 4. 4 plus 1, that's 5. Negative 1 squared, that's 1 plus 1, that's 2. 0 squared is 0. 0 plus 1 is 1. 1 squared is 1. 1 plus 1 is 2. And you can see the pattern. This one must be of 5. So now we can go ahead and we can actually graph these ones as well if you wanted to. I can't really change the color, but I can go to 0, 1. 0, 1, 1 right there. And then I can go to 1, up to 1, 1, 2. And I can go to negative 1, up to 1, 2. And I can go over to negative 2, 1, 2, and up 5, 1, 2, 3, 4, 5. And I can go to the right 2, 1, 2, and then up 5. Now, although this one is not as sharp as the other one. So although I can't use my pen to draw these in, this one would make the shape of a parabola or a U-shaped curve, and this one would make the shape of a V. Really, because this one, A is an absolute value, that makes a V, and this one has a power of 2 in it, so it makes the letter U. Okay? So go ahead and take a look at the lesson check, and do you understand? And I'll see you in class tomorrow. And may the